don't have the year that they were on, but they have. I have the questions here, so we'll go through them and see how they line up. Whatever this turns on. That's always a good sign. No, that's not the one I want. No, right. Still not the one I want. There we go. Right, excellent. Okay, so one of them was okay. So here's the question. Probably another 15, 20 minutes before the sun gets low enough to actually not have the glare on the screen. Give it a square matrix or a two-dimensional array of size n by n. Calculate the absolute difference between the sums of the diagonals. Your program should accept in a positive integer for the user. You should randomly populate the array between numbers -100 and +100. So for example, if the user entered in 3, well, they're going to create a 3 by 3 array, and we're going to populate all of those values with numbers between -100 and 100. So what you need to do is you need to work out the left to right diagonal. So that's top left, middle, bottom right. And then you need to work out the right to left diagonal, top right, middle, bottom left. And you subtract each of them. So 4 subtracting 19 gives you -15, and the absolute value of that is 15. And then say also you can use maths.abs to get absolute value. So basically what math.absolute does is if you send in a number, if it's negative, it will return you back the absolute version, which is basically an unsigned version of that number. And another way of doing it is you don't need to use this plugin at all. You just check to see if the value of this is less than 0. If it is, multiply it by -1. You get the same result. If it's not less than -0, leave it alone. So this is, there's a couple of things that's going on here. The first thing is you have to create a program that takes in user input, and whatever the number the user enters in, it should create a n by n array of that, a two-dimensional array of that size. The second thing is you need to calculate or cycle through every element in that array and populate it with numbers between -100 and +100. Okay, so that's the second thing. And the third, and realistically the most challenging thing, is because you don't know what number the user is going to enter in, you have to work a way of calculating the diagonal, programmatically calculating the diagonal. Okay, so if you look at this box up here, top left, that's 0, 0. This box here is 0, 2. So it's on the top row, but it's the last column. This one here is 1, 1. This one here is 2, 2. This one here is 2, 0. Okay, so what I would suggest, if you were to get something like this in the exam, is now there was one question in this, and basically it was asked during the exam, so the question was, well, what if they enter in 4 by 4? Or sorry, what if they enter 4 and you create a 4 by 4 array? Much more difficult to find the middle element in a 4 by 4 in an even numbered two-dimensional array. So the clarification for this is that you could assume the user will only ever enter in an odd number, so it guarantees there's a middle point in the middle. Okay, so that's the only thing we need to factor in when we're dealing with this. If I look at the length of the array, the length of the array, this array here is 3. The length of the array -1 gives us the last index either going across, so this one here, or down, this one here. Okay, so if you remember with, which one was it? Bubble sort. Bubble sort, the inner loop was from 0 up until the length of the array minus 1 minus I. And that I would grow over time, which means it would change where we were. That's effectively what we're going to approach here. Let's have a look at how we might do this. So, here we have import Java util asterisk. Here we have class. What do we call it? Question 4. Here we have static. Yes. Okay, so I'm going to quickly go through this to get it set up as a Java file, and then when we get to the actual interesting part, we'll stop. Here we're going to need to have a scanner. Actually, you know what? I'm going to jump over the user input. The user input is something you know how to do. So I'm just going to say int size is equal to, and we'll start with 5. I am going to, so that takes in a number from, that's there. We'll assume we've taken user input in for that. We know how to use scanners. We don't do that. We need to randomly populate. So if we need random populate, random or is equal to new random. Okay, we can do that. We're going to say int my array. And this is going to be a two-dimensional array, so I need to have square brackets, square brackets. This is equal to a new int square brackets size, square bracket size. Okay, that will create our n by n array, assuming that n is the value the user enters in. Okay, so that is that there and that there. Okay, so that's the first bit. The next thing we need to do is we need to randomly populate the array. So we have to go through every element in the array, across the top row, all the columns, and down to the next row, all the columns, and so on until we hit the bottom, and randomly populate our values. So we're going to have our loop here, which is like 4 int I is equal to 0. I is less than my array dot length I plus plus. Inside here, we are going to say for int j is equal to 0. J is less than my array square bracket I dot length j. No. Plus. Okay, so that's my loop that will go through every single element. And inside that, I'm going to say my array, position I, position j, is equal to or.next int. Right, and we'll stop here for a minute. So if I were to create numbers between 1 and 100, what do I need to do to my next int here? If it's just 1 and 100.
Plus 1.
Yeah, so you're going to have 100 inside the brackets, which will give you from 0 to 99, and then you got plus 1, so it can be from 1 to 100. Absolutely. Can anyone guess how I might generate negative random numbers? We've never done it, so it would be a guess.
Put inside the brackets minus 100 and
no, remember that what goes inside the bracket is the upper limit, and then what goes outside the bit outside the bracket after the bracket is the shift you're doing to get it in the range you want it. So we want, if we go minus 100 to positive 100, that's 200 numbers we want to generate. And then we want to shift that from 0 to 199 to minus 100 to 100, which is actually 201 numbers.
Could you set it to the value of the highest integer range that you had last week?
Yeah, you could, but then it's way outside minus 100 to 100.
Oh, yeah, sorry, yeah.
So it would be 100 at the brackets and then minus 2 or 1 outside.
Nope. So you're right, basically. That's what I was looking for, is that you would have, rather than plus 1 here, you'd have minus to shift it backwards into the range you want. And it's just the numbers you had backwards. So what we'd want here is that this would generate 201. Okay, so it'll generate from 0 up to 200 of numbers. And actually, sorry, it should be 202. So it'll generate from 0 to 201, just 201 numbers. And we are going to go here, minus 100. Okay, is that right? No, it's not right. Minus 101. Okay, why do we do this? Let's leave this 201. Let's leave this 100 here. Okay. So that's, yeah, no, I was right. Okay, great. So what we've done here is we've said, okay, I want to generate between 0 and 201, or sorry, 0 and 200 is my number range. Okay, which is 201 numbers. And then I'm going to say, actually, do you know what? Any number that generates, subtract 100 away from it. So if it generates 0, it subtracts 100, you get minus 100. If you get 201, it would subtract 100, it would get 101. So actually, that should be 100 there. Or sorry, 200, not 201. No. If it generates 200, this is the maximum. Yes, sorry. So I'm right there. So this, the trick with that part was rather than plus, which is what we're used to doing, shift it up by a certain amount. We can do the same thing by reducing it to make sure that you have this window of possible numbers. And if this goes from 0 up to whatever your upper limit is, you're now just shifting it, well, for you guys, you're shifting it this way, down into the negative range. So there's some of them the positive range, some of them the negative range. And again, the way you work this out is you work out, if I generate the minimum number here, which is 0, and I do this action here, whether it's add or subtract, am I at my lowest acceptable range? If I generate the maximum number, which is 200 out of this, and I subtract 100 away from that, is that up to my maximum desired range? And this will give us that. If it goes 0, if it's minus 100. If I go 200, it'll give me positive 100. Does that make sense? Okay, so that's the first part here. I'm then going to just copy this just to show you how it works for a moment. We're in here. This is going to be system.out print. Okay, now then here. Okay, so this second loop here is just for printing. Okay, so if I were to open up my command prompt and just run this to see if it works so far, and I am well aware you can't actually do this inside your exam script. But at least as I'm going through this, it'll give you an idea of where we're looking at. So there we have our 5 by 5 array. And all of those numbers there, none of them are lower than minus 100, none of them are greater than positive 100. Okay, if I were to run that again, we get a different amount of numbers, or different range of, not different values, different positions, but they're basically the same thing. It looks off here because different amounts of minus and single digits will shuffle it out. If I really wanted to make it look more even, I could do, rather than space, I could do \t, which would give me tab spacing, giving me far more even of a distribution there. It's not perfect, but much easier to kind of see the distribution. So in this scenario here, we would need to work out what is the absolute value of minus 94 plus minus 43 plus minus 5 plus minus 32 plus 30. It's going to be a negative number. And then we also need to work out the value, the total of 46 plus minus 84 plus minus 5 plus 44 plus minus 69. And then we need to subtract those two totals away from each other. And then we need to make sure it's unsigned, that it's a positive iteration of itself. Okay, so what is the index of this number here in I and j? If we have to give it a Cartesian coordinate, what is it? 0, 0, absolutely. And this is a 5 by 5 element array, so what's the bottom right hand corner? 4, 4, exactly. Or the length of whatever size is minus 1. And that's what we're going to use. Because this program says take user input, we don't know what the user's going to enter in. So the only way we can do it is we can say, oh, here's the length of the array. And give me whatever that value is, which would be 1, 2, 3, 4, 5. And then we can take 1 away from it to get the maximum index. Does that make sense? Okay, so what I'm going to do here is I am going to say, so printing is just printing, right? We're going to go here, and we're going to say this is going to be left to right. We're going to create a new variable here called max index, and that is going to be equal to, that's going to be equal to size minus 1. Because the size is going to be the length of the array, and so that minus 1 will give me my maximum value. So I know what the upper and lower range is. Lower range is always going to be 0. The upper range will be the size minus 1. So I need to calculate this. Now, let's go back and have a look at this. So we know this is 0, 1. Then we have 1, 1, 2, 2, 3, 3, 4, 4. Left to right is simple, because left to right is just a loop where both values iterate up. Okay, so let's do left to right first. So int LT or total. And that's going to be equal to 0 to begin with. We're going to have a loop here that goes for, we know it's an n by n array, so we're okay. So I is equal to 0. I is less than my array dot length I plus plus. And this loop here is going to say LT or total is equal to LT or total plus my array okay, and that's I in both positions. And the reason why it's I in both positions is because if we think about it, first number here 0, 0, they're the same. First number here is 1, second number is 1. Then 2, 2, 3, 3, 4, 4. So I can duplicate it there. Does that make sense? Okay, so that can be my left to right. That's a nice simple one to do. That will give me whatever the total of this is. And let's actually print that out. So then here I'm going to say left to right total is LT. Right. Okay, so that will print out whatever the total of that is. Now, going the other way is more complicated. So going the other way, this is 0, 4. Then it's 1, 3. Then it's 2, 2. Then it's 3, 1. Then it's 4, 0. Okay, so one of the axes for the rows is going 0, 1, 2, 3, 4. That's okay. The other one is going 4, 4, 4, 3, 2, 1, 0. And that's the trick to this question. So the first one is going to be, we can reuse this loop. We can actually basically, we're going to say, take all this code here. You take the whole thing. And we're just going to say this is actually going to be right to left. I can get rid of this because I don't need it up here. I need it in the second part. We're going to call this here, no, right to left total. Should be lowercase. This is going to be left. I'll get back to that in a second. I'll say right to left. Total is going to be. Okay, so I have one loop there that's going to go 0, 1, 2, 3, 4. And that will give me my row position for each of them. So I'll be able to say the row array is equal to that plus my array position I. I can do that. I know that's going to stay the same. That will go 0, 1, 2, 3, 4. The other one is going to be something more difficult. It's going to be 4, 3, 2, 1, 0. No. So let's have a look. When this is 0, so when the row value is 0, the column value is 4. When the row value is 1, the column value is 3, which happens to be, if you subtract 1 away from 4, you get 3. When the row value is 2, the column value is 2. If you subtract 2 away from the end of the array, you get 2. Okay, so the size of the array stays the same, and the row we're on is increasing. 0, then 1, then 2, then 3, then 4. So if we subtract the row we're on from the total size of the array, it'll move us to the right column. So what we're saying here is this is going to be equal to max size, what's it called, max index minus I. So max index will always be 4. It's going to start out as 4 minus 0. Gives us 4, that's fine. Then it'll become 4 minus 1. Then it'll become 4 minus 2, 4 minus 3, and eventually 4 minus 4, which will be the bottom row, first column, and at that point our loop will stop. Does that make sense? Yeah? Okay. So let's test this. Because random numbers are going to be left at different values. Okay. So we have here minus 28 plus 90 plus minus 10 plus minus 36 plus minus 10 is going to give us 6, which kind of makes sense. We have one big positive number, and then we have a whole load of negative numbers which are getting removed off it. So 10 and 10 is 20, that's 56, that's going to be 76, and then that's going to be 84. 84 subtract away. 90 gives us 6. Yes, that makes sense. Let's go the other way. 91 plus minus 93. So we're at negative 2 at this point. Plus minus 10, we're at negative, we're at negative 12. Plus 30, so we're at positive 18. Plus minus 36, we're now at negative 18. Okay, so we can see how that calculation has built up. If I run that again, I'll get different numbers. Let me scroll up there, let's see. I'll get different numbers, but you can see that it's essentially doing the same calculation, so it's working. If I go into my code, and I change this from a 5 by 5 array to a 3 by 3 array. I won't do it bigger than that because it won't look right on the screen. The code still works, and this is the key factor. I want it to work because I don't know what the user can enter as the size of the array. So 2 plus 6 is going to give us 8, plus minus 24 gives us minus 16. That's good. Then we have minus 95 plus 6, so we have minus 89, plus minus 74 gives us minus 163. Okay, so we can see that works. If I wanted to ramp it up to a 7 by 7 array, numbers are bigger, same calculation. Okay, so the mathematical way we've looked at that of saying, do you know what? Where are we? Here, this bit here, I know that's going to track because as I go rows 0, 1, 2, 3, 4, that happens to correspond with the number of positions I'm working from the back of the array toward the front column. So it's going to go in the diagonal line. Does that make sense? And then the last thing we need to do is we actually need to calculate the absolute value. So here, I'm not going to use the plugin because I think that's just one extra thing you don't need to worry about. If you want, well, I'll do it both. I'll do it both ways. Okay, so here we're going to have int total, grand total is equal to left to right total minus right to left total. Okay, and then here I can say if grand total is less than 0, in other words, if it's a negative number, well, then what I'm going to do here is I'm going to say grand total is equal to grand total multiplied by minus 1. Okay, so let's test this one, and then we'll come back to actually. Let me go back to 5 by 5, so it's manageable on the screen. Okay, so there we are. So really all we're interested in here is if I subtract 141 away from 94, I'm going to be left with minus 47, and then when I multiply that by minus 1, I'm left with 47. And then let's just do the math absolute. So I probably, let's see what I can do here. So here then I can also say, okay, so I have to do it here. Let's see. Math.abs. Okay, so we should get the same number. Yeah. So here we can see that our numbers are minus 30, and then from minus 30 we subtract 122. And for subtraction, that will bring it down to minus 52, and we can see that whether we did it using the plugin, the math.absolute, or we did it just by multiplying minus 1, we get the same answer, and that's kind of what we're looking for. So that was the first question that was sent to me. 3 challenging bits in that, or three specific things I'd be looking for as I'm grading. The first one is actually creating the array. Okay, if there are 15 marks going for a question like that now, creating the array is probably 3 marks. It's not a lot, but it's something you have to do. The next one is randomly populating the array between negative and positive. That's probably 4 marks. Okay, because that's the challenge. You have to figure out how to do that. Not only fill every element of the array, but also have the correct range of numbers. Calculating the differences. Left to right is probably 2 marks. Right to left is probably 3 marks. Is that right? Yeah. And then the remaining marks are just going for the output. So you can see that each part of the question gives you a certain amount of grades. You can also see that in my very quick kind of saying, well, here's where I do the marks for that. And I didn't actually go search through the exam paper to see which year that was. I didn't look at the marking scheme for it specifically to find out what I would give, but off the top of my head, that's about sensible. Things like the imports, or have you got public static void main, or have you got all your semicolons? That's quite fluid when I'm correcting. If you can show me you've the right approach to the problem, you're going to get a good chunk of the marks. So don't be fretting too much about, oh, I've left out a semicolon, or I've left out a bracket or a quotation mark. They're trivial mistakes. They're the type of mistakes if you actually were typing in the machine, you wouldn't make them. Or I'd never see them because you go, oh yeah, no, I fixed that, and you send up. You might get the code working, but you wouldn't have those issues. So I don't really worry too much about them in the examination. I'm more, what's your approach to the problem? How did you actually solve that problem? If you didn't get it all done, well, did you get the first bit? Could you create an n by n 2-dimensional array? If you got that done, could you fill it with random numbers? Did you use the right range of random numbers? I have had people who have done this, have done all of the question except for the negative random number range. And they've just gone 1 to 100. And essentially, it's the exact same question. It's just that they haven't figured out in the exam time how to shift the range of random numbers. I've had people who have done everything to this point, and through exam pressure, lack of time, whatever it might be, they just didn't do the last bit. Didn't understand or they didn't remember what's an absolute number from math. And they didn't ask during the exam. Like if you asked me, this is a good example here, if you ask me in the exam, oh, how do I do an absolute number? Like that's something I can absolutely tell you. Not how, but I can tell you what an absolute number is. How to do it is something you have to figure out. Okay, anyone have got any questions on that? No? Okay. Right. Since I haven't got the text file done, we will leave this alone. Well, we won't go through a full code solution of this, but we'll have a look at what we would do. Write a Java program that would read in a text file called list.txt and write to another text file called distribution.txt. Each line of the input file consists of a list of numbers from 0 to 9. The lines have no extra spaces, no extra tabs at the beginning or the end. The program shall write out the distribution of each number in the input file. So the distribution means the frequency. How often does that number occur? So we have a couple of things we have to think about. We are going to read in a string, and we know that in that string, the only characters we're going to be dealing with is 0 to 9. So 0, 1, 2, 4 to 9. That's good. Yes, we're dealing with characters, but we've quite a small set to look at. We also know that we need to kind of keep track. So there may be multiple lines of text. It's not just one string we're reading in. It's multiple strings. And we have to give an output here of, okay, in the text file, 0 occurred three times. 1 occurs 3 times, 2 occurs 4 times. So the asterisks here represent how many times that occurred. So we have a couple of things we can kind of guarantee on to minimize our search problem or our issue. We are going to need to have a way of reading in the text file. Fine, text file problems. We're going to need to have our scanner to read that in. We're going to need to have a way of writing out to our text file. We need to have our print writer. We're going to need a way of reading everything in our text file. So we're going to have that loop that goes while our scanner has an X. So we read in, or read in, or read in, or read in. We need a way of maintaining how many times we've come across each number. We need a way of determining the character that I'm looking at. What number is that? And we need a way of writing all of that out. Asterisks, not a number. So I don't write the number 3 for 0. I write 3 asterisks. So the file access stuff, that's kind of the stuff that I'm assuming everybody's okay with. We need a scanner for reading in the file. We need a print writer for writing it in the file. When we're accessing those files, they need to be inside a try-catch block. Okay, that's the stuff that any text file question, you have to have those elements. We're also going to need a loop, or while scanner has next, that's going to read in every element, and that will obviously be added to be a string. We're going to need another loop inside there to calculate its way through each of the numbers. Actually, do you know what? Let's quickly create this. There. Here, let's see your new text file. This is going to be called list.txt. I'm going to be super lazy and say, there are all the numbers I put in. Okay. I'm going to go here and go file, save as. Expression 2, confusing me. Okay. Ready. Save as. Expression 2. Right. Okay, so up here we're going to need that. We're also going to need our import state or our IO statement. This is called 2A. With all units. Okay. So there's actually no print in this top. So we're going to have a scanner here, which is equal to in file. That's equal to null to begin with. And we're going to have a print writer. That's equal to out file. And that's also equal to null to begin with. And this is kind of how we've done it. We set these up as null to begin with. And then what we do is we say try. And then here we're going to have catch, exception, E. And I'm not going to put any comment in there because I obviously don't care about it at the moment. Here I'm going to say that in file is equal to new scanner, new file. What do I call that? List.txt. Okay, that will do that. Here I'm also going to say out file is equal to new print writer. It's going to be just trip.txt. Okay, I'm going to say while in file dot
has next line. Here I'm going to say string s is equal to infile dot next line. Okay, I'm kind of rocketing through this bit here because this is the stuff that's common in basically every text file question we've looked at. I need to do something here. String. And when I finish doing that, I'm going to say here infile dot close. Let's go back and have a look at the question. So I need to read in the text, which I've basically got that loop there. I'm just going to read it in one line at a time. I now need to do something with the string. So I need to go through the string and go, this character here, what is that? And then keep a record of how many times I've got it. In my eyes, the most sensible way of hanging on to stuff we have here is by using an array. We have 0 to 9, so it's a 10-element integer array, because all we're keeping track of is the numbers. We'll figure out how we turn them into asterisks later on, but this represents, there are 3 ones across these 2 lines of text, so let's have a look at that. So I'm going to create a 10-element integer array, and my strategy will be, as I go through the characters, I'm going to work out somehow what value they are. If they're a 0 or a 1 or a 2 or a 3, and I'm going to increment that index in my array. So if I find a 0, I'm going to increment index 0, because it'll build it up by whatever it is. If I find a 5, it'll increase 5, and so on. And when I've read the entire file, well, then I go back to my array, and that's where I try to figure out how do I convert this from numbers to asterisks. So here, what I'm going to do is I'm going to say string s to that. I'm going to have here for int I is equal to 0, I is less than s.length, I plus plus. Okay, so that'll cycle through every string each time. I need to do something inside there. Outside of here, I also need to say int distrib is equal to new int. And I know it's going to be 10, and the reason why I know it's going to be 10 is because the question tells me I only will have characters between 0, 1, 2, 3, 4, 5, up to 9. So I'm safe in hard coding that there. This is the tricky bit. I need to figure out that character that I'm looking at. So char c is equal to s dot char at I. Okay. I need to see what the alphabetic character is of that. Essentially, what I want to do is I want to subtract, or I want to reduce, I want to convert. I can convert it to an integer. So I can take this character here, character C, and I can convert it to an integer. But if you remember the Ascii table, that doesn't do it. It does that. That does not do us a huge amount of help, because it's not 0, 1, 2, 3, 4, 5 up to 9 are not the first 10 elements in the Ascii table. They're the numbers are actually in between the lowercase and the uppercase numbers, the uppercase and lowercase numbers. So we have to figure out where they are there. The nice thing is I can treat everything as if it was just numbers. I can treat the characters like they're numbers, and it can work that way. So if I've got, let's see, what way would I do it here? If I the number of character, if I had the character 0, okay, and I subtracted 0 away from that, I'd have 0. Yeah, 0 from 0 is 0. If I had the character 1 and I subtracted 0 away from it, I'd have 1. Do you know what I mean? Does that make sense? So if we have a look, if we go to the Ascii table, I think after all these years of teaching this, I would have a copy of this permanently somewhere. Images. Oh, Lord. There we go. Okay, so
Here are my characters here. 48 is the decimal number. So if I subtract 48 from 48, I'm left with 0. If I subtract 48 away from 49, I'm left with 1, which happens to be the number I'm looking for. If I subtract 48 away from 50, I'm left with 2. So you can kind of see where I'm going from here. I'll use a little bit of calculation to work that out. So here's how I'm going to do it. I'm going to go back to my code, and I'm going to say int x is equal to c minus. This is this will be my first attempt. It probably is not going to work, but this is my first attempt. C minus whatever the character 0 is. So if I have 0, it'll give me 0. 48 minus 48 gives me 0. If I have 9, which will be 57, I'll have 57 minus 48, which will give me 9. That make sense? So now it gives me 0 to 9, which coincidentally happens to be the range of indices I have inside my array. So what I can say here is, once I've worked that out, I can say, what did I call it, distrib x plus plus. That's all, okay? I'm just going to very quickly compile that to see if it works. I haven't got any mistakes in there. So here we have Java C, question 2A. Excellent, I got a problem here. The problem is I'm missing a bracket. Okay, well, that's an easy one to fix. And if this happened in your exam, I probably would even notice or count it. I know what you're trying to say. You're one bracket off. Realistically, that's not going to. Now, okay, info. Okay, that's another one. It's very easy to tell what's an uppercase and lowercase when I am there. Okay, great. So if I ran that code, it doesn't do it because we haven't written, and it doesn't give us an output file here. Oh no, actually we have, but there's nothing written to it. We haven't got to the writing part yet. Okay, so we can take it that this code as we have it now gives us a way of processing through every single character that we're going to come across in the text file, reducing whatever character that is to the range of 0 to 9, and then adding it to an array. And what we need to do here on line 24 is then cycle through that array and figure out, well, how do we do asterisks? And then compile that to a string, write it to the text file, move on to the next index in the array. Before I move on, is everybody okay with this here? Is there any questions? It really is this. That's the trick. Now you could, there are different, again, I'm trying to come up with the most straightforward and fastest writing solution, the thing that would take the least amount of content to write. You absolutely could have if statements. If 0, if 1, if 2, and then increment to the correct. Absolutely you could have that. It's a lot more writing. And I suppose in my head, the way I would look at that is, if I have an idea of how to do it, it will take me less time to stop and to think, and then to write out a good effort at the code rather than just go if 0, if 1, if 2, if 3. It's really easy for me to say that now when I'm not in an exam and I actually don't need to take an exam and there isn't really a time pressure. Very, very different in an exam environment. So if your immediate thing is, I haven't a clue, I'm just going to have 10 if statements, go for it. Because if it works, you get the grade. The difference in grades between having something like one line here to mathematically calculate it and having 10 if-else if statements is, let's say, 15 marks for this, 13 marks for the other. So you lose 1 or 2 marks because it's obvious that there has to be a neater way to do it. If you are 15 minutes is 20, or 15 marks, 22 minutes, if you're frantically writing to catch up and you haven't spent a load of time thinking, but you're frantically writing to catch up and try to do it, there probably is a much smaller solution than what you're doing. It does not mean that your solution won't work.
Okay, it's just a case of, again, if I pick numbers, I usually pick ridiculously large numbers to stop people hard coding it. Like calculate the prime numbers between 1 and 35,000. No one can do that by hand in 22 minutes. So it's to help when you get to about 43 or whatever is the prime number around there, you can go, maybe I'm doing this wrong, and you could have think about the mathematical way of doing it at that point. Okay, so that's reading in the numbers and building up our array here. What I need to do now after I close off that file is I need to have a loop that's going to go from the index 0 to index 9 of that array, take the number inside that array, and have another loop to build a string of asterisks, and then to output it right into the file. So that's what I'm going to do here. Okay, so here we're going to have for int I is equal to 0, I is less than distrib.length I plus plus. Okay, that will go through every index in my array. Inside that, I am going to have a string called A for asterisks, and start that out as empty. And then here I'm going to say for int j is equal to 0, j is less than distrib I. So whatever the value is inside there, it's less. It'll keep going once less than that. And then we're going to go j plus plus. And here is going to be a is equal to a plus an asterisk. So the first loop, the outer loop on line 25 is going to go index 0, index 1, index 2, index 3, index 4, index 5. The inner loop is going to take the number inside there, and the output will effectively be, what if the number was 4, the output will be 4 asterisks together. It starts off with an empty string and goes, is 0 less than 4? Yes. Okay, add an asterisk. Increase. Is 1 less than 4? Yes, add an asterisk. Is 2 less than 4? Yes, add an asterisk. Is 3 less than 4? Yes, add an asterisk. We're up to 4 asterisks now. Is 4 less than 4? No. Okay, stop. And so it has all 4 asterisks at that point. And the last thing we need to do is we then need to kind of go, okay, outfile dot println is equal to, what way do I phrase it here? So it would be that colon and then how many asterisks? Grand. So that's going to be equal to I, which is that character, plus space colon space plus A. Okay, so that will give us the index we're at, or in our case, the number we're dealing with, a colon in between it, and then however many asterisks this actually built up. So to do that, it'll write it out to the text file. It'll go back around again. I goes up to 1. It resets this to a brand new string. It starts counting from 0 up to whatever, however many ones we encountered in that text file. It'll build an asterisk for each one of those there. It'll go 1 plus colon plus the number of asterisks, and it'll build it up over time. Okay, and the very last thing we need to do is we need to say here, outfile dot close. Okay, so let's go back and have a look at that before we run it to make sure. So we have our imports up at the top. We have our scanner and our outfile or our print writer, and they're both set to null to begin with. And we have an integer array which is 10 elements, because we know that the only possible characters inside this text file are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We are going to access our file we're reading from. We're going to create the file we're writing to. We're going to have a loop that's going to go until we're finished reading from that text file. For every line of that text file, we're going to copy it out to a string. We're then going to go through every character in the string. We're going to get that current character. We're then going to subtract whatever the value of character 0 is away from the character we're looking at. So again, if it's 0, 0 minus 0 will leave us with 0. So go back and look at our Ascii table. 48 minus 48 leaves us with 0. If it's 5, it'll be 53 minus 48 will leave us with 5. And that will tell us what the value of x is going to be. And conveniently, because we're dealing with 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can relate that specifically to the index inside our array that we created up there. And so this loop here will go through all of the text file, go through every character inside that text file, and increment the correct position in the array. Once we've done that, once we've built up our array, we're then going to go back and we're going to cycle through the whole array again. And then we're going to take a specific point, so position I in that array, and we're going to, whatever the value that is, because it'll be a numerical value, it's an integer array, we're going to build a string of asterisks to match it. So if we've got 9 of whatever number it is, we'll have 9 asterisks left there. And the last thing we do is we write out the number we're dealing with, colon, and however many asterisks we've built up, out to our out file here. And very important, we close off the file when we're finished, otherwise nothing gets saved. So let's save this and check if this works. Okay, and there's no output to the program because here we have our distribution. Now, let's compare that to our file here. You can see that we have the same. We use the same input, we use the same text to begin with. We have 3 for 0, 3 for 1, 4 for 2, 5 for 3, 5 for 4, 5 for 5, 2 for 6, nothing for 7, 1 for 8, and nothing for 9. Okay? Now, if you go back and have a look at this question here, there are a couple of things which we can get out of the way really quickly. Text file access. How do we read into a text file? How do we write out to a text file? If you go back and have a look at all of the questions that we've done, and all the text files, that's kind of consistent. That's something that you should just be able to regurgitate out onto the page really quickly without much thinking, because it's almost identical in every one. We need to have our scanner, we need to have our print writer, we need to have our try-catch. We need to have our loop to go through the file we're reading from. Once you've all of that, you then go back and have a look at the question. Okay. Or what they want to do. You can say, okay, well, here's my input. I don't want to convert it into this. And that's where the thinking challenge will be. Now, that one there was a more it was a step away from most of the other questions you see about text files. Most of the questions you see about text files, it is read in the string, check a number of the first characters. If it matches your criteria, it's equal to 3, it's greater than 3, it's less than 3, whether it's good movies, 3 stars, or bad movies, they're usually the way I would go. And then go from the first space character to the end substring and write that out in the text file. There's still a lot of work on that, but the reason why people will look at this and go, oh, that's a harder question, is because this is different to the other ones. We're still doing the same rough amount of work. The trick, or the thing that I was hoping people would pick up on, is that you need an array, or the best way of storing this is an array. These just relate to numbers: 3, 3, 4, 5, 5, 5, 2, 0, 1, 2, 0, 0. So if you pick that up, great. If you don't, like with the previous question, and you just have 10 integer variables, fine. Your penalty is a mark or 2 in total and time, because obviously writing that much code is going to be more time consuming. It also means that when you actually check the character, you have to be quite specific about which variable you write it to. Whereas the way we did it, these 2 lines here, these 3 lines here, I suppose, allow you to end up with a number which tells you exactly where in that array to write it. And that just means that we can scale this up and down. It doesn't matter if I extend that out to the entire typed keyboard, uppercase letters, lowercase letters, symbols, and numbers. All I would actually need to change is what's my baseline here, and how big is the total array. That's really it. Apart from that, the entire question would work as is. Okay, that was the second question. I'm going to put all these up onto the OneDrive once I'm done here. Now, okay, we're not going to go through this because I can guarantee this question is not coming up this year. This is, so we did prime numbers, and the way we look at prime numbers is what's called a brute force search, which is, I've got one number, I'm going to check every number between 2 and 1 less than the number I'm looking at to see do any of them divide in. It works, but it's incredibly inefficient. This is the sieve of Arachnases, is a much quicker way. And this is the least efficient sieve that there is. There are far more complicated and far more advanced sieves than this. Okay, so the idea of a sieve is exactly like a sieve in the kitchen. It removes, or it allows for certain pieces of content to just be removed. And what you're left with at the end is actually what you want. You're boiling a pot of rice or a pot of pasta, you pour the whole pot, water and starch molecules and content into the sieve. It all drains through, and what you're left with is the rice or the pasta. All of the other stuff is gone down the drain out of the kitchen burner. How this would work is you are going to create an array of, in this example here, 117,000. You can see here, this is a stupid big number to stop people trying to do this by hand. Because I have got, when I used to use small numbers, I'll find the first 25 prime numbers that people would literally hard code. They'd spend the 20 minutes or so working out what prime numbers there were and hard code out the values. So just printed out the values, it didn't actually do any calculation. So the way this works is you create an array of 117,001 numbers. So it's one bigger than whatever the first number you're looking for. And the array is not going to be an integer array. It's going to be a Boolean array. And initially everything's set to true. And what actually happens here is when you come across a value that's set to true, you go from there to the end of the array, jumping up in increments of whatever that index is, and set every other value after that to false. Because if you think about it, if you find a number that's true, 2 is a prime number, which means that 4, 6, 8, 10, 12, 16, so on. None of them can be prime numbers. So no multiple of 2 can be a prime number. 3 is a prime number. No multiple of 3 can be a prime number, because 3 can divide into it. And so what happens is you start off with 117,000 numbers, and immediately first pass through, you remove half of them. So this is what it looks like. I'll show you really quickly what it looks like. I can put up the code for it if you want, but I can guarantee you're not going to get asked this. And Wikipedia has a wonderful, now, okay. So if you watch how this works, we pick number 2, we're going to remove all of the even numbers. So 2 is prime, everything that's a multiple of 2 isn't. 3 is prime, remove all the multiples of 3. 4 isn't prime, 5 is prime, so remove all the multiples of 5. 6 isn't prime, 7 is, remove all the multiples of 7. 8, 9, 10 aren't, 11 is, 13 is, 17 is. So you can see what's happening now is you're basically going through it. Are there any multiples of these that are still marked as true? And that's how that prime sieve works. And obviously it works much faster than that. But that gives you an idea of how it's going to work. I'm not going to spend a huge amount of time on this. I'll put up the code for it. Actually, do you know what? I'll send you to the, I think it's Stanford University, have a really good lecture on it with the sample code in Java and everything, which shows you how fast it is. I think you can do the first 2 billion numbers in about 30 seconds. It's really quick. But the Wikipedia page gives you a really good explanation of what it's doing. It's just eliminating, it's switching off the numbers. To begin with, they're super optimistic. Every number is prime. And as soon as we find a number that is prime, we turn off all of the multiples. And we move on to the next one. Okay. Right, okay, so question 3, camel case. So when we're naming methods and variables, we use camel case, where we are going to capitalize each subsequent word. And actually, do you know what? Camel case itself here is not written in camel case, but we'll come back to that. So it's a concatenation of 1 or 2 words consisting of English letters, right? All letters in the first word are lowercase. For each subsequent word, the first letter is uppercase and the rest of it is lowercase. What you have to do is you have to create a method that takes in a sequence of words in camel case as a string allows. So you take in one string from the user, and the method should return back the number of words in the string. So for example, if your input is this is a really long string that you are processing, what we're going to work out is, well, we have one word there, and then so we start our counter at 1, and we count basically just count the uppercase letters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So here's the trick to this question. You just need to understand what you're looking for. In this question here, I'm only looking for uppercase letters. That's it. When you reduce the question down to you were only looking for uppercase letters, it becomes much simpler. Because we've done loads of these. We've done questions where we're only looking for vowels. We've done questions where we're only looking for the letter E. We've done questions where we're only looking for spaces. We're only looking for full stops. Here, we're looking for any letter that's uppercase. So if I take, let's go and implement it. Question 3. As okay, so 6. 3. I'm going to get rid of all that stuff here. Stuff here. Oh, that. Okay, so I'm going to create a string here. I'm going to use the same string to begin with. The string s is equal to that string there. I'm going to say system.out print ln camel case s. Okay, so this is where I'm going to call the method, and it'll print out wherever the result is turned back out. That's all that's in my public static void main. You're not required to write that at all. I just need it for testing the program. What you are required to write is your public static int. So you can see here, this program is going to return the number of words. We don't have, it's 2.5 words. It's going to be an integer because we're only dealing with whole numbers. So it's going to be public static int. We're going to call this camel case, and it's going to take in a string s. Okay, so I've asked you to write a method. So part of the grade is going for that. Have you got public? Have you got static? Have you got the right return type? And have you got the correct inputs? Okay.
So yeah.
Yep.
I just wondering if that, for example, it says like create a method.
Yes.
Do we still have to do everything else?
Nope. If you create a method, you would only need to do whatever can be inside those brackets there. And I need to write the rest of it so that it actually runs and I can show you working it. For you, you only need to do that. Now, in the exact same way as I said, if you want to write an if statement around question 1, part 1, those Boolean statements, because it makes it easier for you, do it. If you want to write a full program, go ahead. But if you haven't got the method, like if you write this all of this just in public static void main, you will lose marks for that. If you write the public static void main like I'm writing it here to allow for me to run the program, no penalty on that. Your time is your penalty more than a grade. Make sense?
Yeah.
And if you mess up, if you've got mistakes in this part, no penalty. It won't make a difference because it's not what I'm asking you the question. Okay. So inside here, I'm going to have int total. Okay. And we'll start the counter. Now, here's the trick. To get almost full marks here, you do what you're instinctually going to do. I've created a counter, set it to 0. But we know that for sending in a string, the first word, and we're counting the uppercase letters, that's fine. That'll give us, there are 9 uppercase letters in that string. There are 10 words, because the first word is lowercase, all lowercase. So what I'm going to do here is I'm going to say, start my counter at 1, because we'll always have one word inside our case. And then I'm going to have my loop for int I is equal to 0, I is less than s.length, and then I plus plus, car C is equal to s dot car at. Okay, so get the current character. Right. So we're going to go character by character through the string. We're going to get that character, and we're going to evaluate, is this an uppercase letter or not? Very much like the previous question, where you could reduce down your work by, sorry, not the SIP question, the previous question I did the code for, where you could reduce down your work by thinking about how those numbers are, or how those characters are arranged in the Ascii table. We know that A to Z are one continuous. It goes A all the way to Z. There's no other letters, or no other characters in there. There's no numbers, no symbols, no lowercase letters. Starts at uppercase A, and it runs all the way through the alphabet uppercase until we get to uppercase Z. So what I can say here is I can have an if statement. If C is greater than or equal to A, and C is less than or equal to Z, well, then I found an uppercase letter. Make sense? And so the key here, what I'm looking for here in the evaluation, is it's greater than and equal to, unless you can remember the character that is before and the character that is after. I can't. If you can, great. I'll go and check it if I find it in your exam script. But if I can't remember it, greater than or equal to means it'll include A, and less than or equal to means it includes Z. And the second thing is, this has to be an AND gate. Any letter in the alphabet has to be both greater than or equal to A, so it meets the lower limit, and less than or equal to Z. So it's somewhere in between A and Z. Because if we have OR in there, it means it'll actually count any number on the Ascii table. Because we might do lowercase alphabet, which comes after the uppercase alphabet, and they're all going to be greater than capital A, but they're not going to be less than Z. I might do space, which is 32, well before either alphabet. It won't be larger than A, but it will be less than Z. So it has to be and. It has to be both of them to say, here's your upper bound and here's your lower bound. And if I find this, well, then here I'm going to say total plus plus. That's it. And when that loop is finished, we return back the value of total. Okay, so that's lines 12 down to 22. That's all I'll be looking for in that question for a solution, okay? When you see it like that, it's not a very big solution. Where your grade points are going to come in is, have you got the signature correct? Does your counter start at 1, or do you factor in that the first word is all lowercase in some way? It doesn't have to start with 1. You could actually go +1 here before you return it back. But somewhere do you factor that in? You're going to get some marks for cycling through that string, character by character. You're going to get some marks for making sure that it's in the right range, and you're going to get some marks for incrementing when you find an uppercase letter. This will, no matter what we have inside our string, and you can see here, this is a big string with lots of characters in here. It will only ever increment when it comes across an uppercase letter. No lowercase letters, no symbols, no numbers. So let's check it out and see if it works. This. I think it's 10 there. And if I were to add to that string, or actually delete from the string here, so get rid of our processing, so it reduces down to 8, hopefully. This is 8. Okay? A lot of these questions, when you look at them, or when you look at the solution, you can realize that it's not actually it's not actually as difficult as they seem. There are specific challenges in every question, and there are specific things like, for example, of the ones we looked at today, I think in an exam environment, the most difficult one is that subtracting the character 0 away from your current character to get where it is. And that's more of a having the luxury to stop and think, which in an exam is tough to do. But the rest of like camel case, once you realize, I'm counting the uppercase letters in a string. If I just said, count the uppercase letters in a string and return back the value, everybody here would get it right. Because that's something we've done loads. But when I say, it's camel case, it matches this, you have to look at that problem and go, okay, how can I reduce this down to something simpler for me? How can I reduce it down to what I know I can do or what I know has been asked? And that's a skill that you have to develop over time. That's a skill that we're starting now, and I'm going to spend, the first year exam is mostly assessing that. It's assessed implicitly in second year, third year, and fourth year, but there's no, the exams for, at least for the core programming, aren't as abstract. They're much more direct. Here, create a binary search tree, or create encapsulation for this, or do a polymorphic bag. Okay, or say, do this thing. We've looked at it, we've looked at loads of stuff. First year is very much problem solving. Here's a problem. Can you identify the things that are actually important in here? Can you identify what you need to do as you're going through? Right, that was actually the last question, was it? Yes, that was the last question.
The question was, let's say Swedish, where they have, special characters, we will just add those special characters.
Yes, now, the luxury you're going to have there is ASCII doesn't factor in anything but a Latin alphabet. So you don't have Cyrillic, you don't have Swedish, you don't have umlauts, you don't have any of the other weird characters that other nationalities have. You don't have Pinyin, Chinese, Unicode, if we were using rather than ASCII, Unicode is where like emojis can be placed in keywords. So that's a far, far bigger set. We don't look at that. But yes, effectively, it would just be changing the ranges. And for us, we need Unicode getting, see, we have the luxury here of, if I want to use a character, between the range, I can just type a character. With Unicode, you go U, and then you actually type in the 5-digit code for that Unicode character. It's much more complicated. So no, that definitely will not come up. I will not be. There is no Swedish chef question coming up in the exam. Okay, so they were the questions that were submitted to me between or before today. I went through. Does anyone have any other questions?
Quick one, just about question one, the
Yes.
You were looking for for leap year.
Yes.
Would it be something like G module 4 equals 0, G module 100 equals 0, G module
400. No, so basically, so it's a leap year is any year that is divisible by 4 and not divisible by 100, but is divisible by 400. Okay, so 2008 is a leap year, divisible by 4. Okay, that's cool. 2000 is a leap year because it's divisible by 4. It's also divisible by 400. 1900 is not a leap year. It's a weird rule. So in those 2 marks, if you just did A mod 4 equals 0, you got 1 marks. If the other, basically, if it's mod 4 and mod 400, but not mod 100, then you get 2 marks. Okay, so again, time versus retention for an extra 1 mark on the exam. Don't kill yourself if you can't remember. Just go with that mod 4. Okay, but yeah, the actual algorithm for leap years is way more complicated than. I mean, I suppose if you think about our generation, the only century turning point we've come across is 2000. So we haven't, like, 2100 won't be a leap year. 1900 wasn't a leap year. 1600 was a leap year. So I think it's just the year that we're living in, we haven't come across a century year which hasn't been also a 400th year as well. Does that make sense?
Thanks.
There's a podcast with Joe Rogan where Neil deGrasse Tyson explains leap years very well.
I'm not going to bad.
Yeah.
Yeah, leap years are weird. Anyone got any other questions? Any topic you're a bit bobbing on? Or is it just a matter of sitting down and doing the work and going through the content, or going through, getting yourself up to speed and whatever? I'm hoping I made good progress on one of my other modules today. That's kind of the biggest amount of content. So I'm hoping to have worksheet 2 results printed out to you tomorrow. And then I will get started on the last assignment, which you'll have before Monday. So you'll have all of your grades out and published. If, for whatever reason, we get to next Monday, and you can see that all the grades have been published, and you can't see your grade for something, send me an email to let me know. There's always a human error chance I've missed it, but I'm kind of assuming now, if it's not the workbook 2, and if it's not the last assignment you just submitted, you would have come to me and said, hey, I haven't got the result for a zombie dice or whatever it is. But if you haven't got it, let me know, because there might have been an issue with me accepting it off Moodle for whatever reason. There might have been just a human error, I might have skipped it, or there might be some other reason. If you get in contact, I can get it looked at ahead of the exams, ahead of the exam board, which always makes it easier. You can also come back after the exam board and go, hang on, this grade seems lower. I was doing really well. Where's my assignment 3 result? And then we can go back and we do it. And then it involves more work on the college's part, because we've gone past the official board, so they need kind of paperwork and reports filled out. It can still get done. It's just there's a bigger delay. If you contact me before the exams, it's done. This is only me that has to do it.
Do you take the spreadsheet back down the?
Did I?
Did
Did I update it, or did I? Was it due to be updated? I can't remember. No, it should be in the forum. I'll have a look for you now. Part-time. +4.
Is there a calculator?
No.
Yeah.
Did I put it there?
Yeah, yeah.
There's the form. There, grade calculator. Yeah. So it's there.
Alright.
Okay. But you know the weighting, so it's something you can work out with a calculator if for whatever. But if that's wrong, in the sense of if you put in 100 across everything, it doesn't total out to 100. Let me know. I'll figure out where it's wrong and I'll fix it.
No, it's working.
Okay, good. No other questions? All right, we have like another half an hour officially before the class finishes. Do you want me to do anything? Do you want to head off early? Stare awkwardly at each other for half an hour?
I haven't submitted the last assignment. If I do that tomorrow, do I get normal deduction of points, or today's last chance to do it?
Get it in as fast as you can.
Okay.
I'll be as fair as I can.
How would you find the multiple? Another 5 million question and multiple of 51, let's say.
Okay. So this is again learning the language of the exam. So if a number is divisible by something else, that's an easy one to go for, because you got to have number 1 divisor with modulus in between equals to 0. But a multiple is the same thing. If x is a multiple of 51, you have x mod 51 equal to 0. Because if it's a multiple of 51, if you divide 51 into it, you should be left with a whole number, not with no remainder. So for example, if I were to open up a calculator and say, okay, so 51 multiplied by 14. Right, so 714 is a multiple of 51. And do you know how I know that? Because if I take 741 and I divide that, or 714, and I divide that by 51, I'm left with a whole number. There is no remainder. It goes in 14 times and nothing left over. So if you get the is a multiple part of the question, it's modulus. That's what I'm looking for there. Whereas if I had 717 divided by 51, that doesn't go in evenly because you can see there's a leftover. There's a decimal point part there. Okay, but again, the key is I don't want a number. I want the calculation for how I work out if any number would fall into that category. All right, folks, if there's no other questions, thank you very much for coming in. I'll stop this here. And